Good morning. We will continue our discussion about cyclotron in this class. If you can recall, in the last class we learned about the principle and the construction of a cyclotron. In this today's class we will continue with that discussion. So we'll go on to the part of working of cyclotron. Let us recall what we have learned in the last session. So we have seen the principle. The cyclotron works on the presence of both electric field and the magnetic field B. So a charged particle will be accelerated in the presence of electric field, and then the magnetic field makes it move in a circular path, so that repeatedly when it moves it gains very high energy. Now if you go to the construction part, it has two electromagnets which will produce the required magnetic field, and there are two metal D-shaped segments, and there is a gap between the D-shaped segment where we at the center we place the charged particle, and the D-shaped metal is connected to an alternating current source which will produce the electric field. Now this is about the construction, and this in detail we have studied in our last session, so you may go and refer the last session for more about the construction. Now in today's class we will go on to the working part. Now let us say at any instant the potential of the high frequency oscillator is in such a way that it makes D1 positive and D2 negative. Now the potential of this is such that I'll show you here. We are assuming that this side is positive, that is D1 is positive, and D2 is negative. At any instant, just assume that D1 is positive and D2 is negative. Now what happens? A positive ion starting from source S will be attracted by the D2. Now suppose assume that this point is S, let me say the source is S. If we have a positive ion here, this positive ion is attracted by D2 because D2 is negative. So we know unlike charges attract. Now the positive ion at the source S or at P is attracted towards D2. Now in the construction we have seen that inside this metal D-shaped segment the ion is acted only by the magnetic field, because the metal segment is shielded such that the particle or the ion inside this metal D-shaped segment is acted only by the magnetic field. And as we know, when the ion enters the magnetic field in such a way that the velocity is perpendicular to the field, then they follow a circular path. So inside this shield or inside the segment the ion follows a circular path, so it is shown by the semicircular path. Now when it reaches the edge of the D2, if we adjust the frequency in such a way that the polarity of D1 and D2 changes, then what happens? We'll see. Now a positive ion starting from source S will be attracted by D2. Since uniform magnetic field B acts at right angles to the plane of the Ds, the positively charged ion of the charge Q and mass m will move in a circular motion of radius me divided by qb, where v is the speed of the particle and it is for the time being it is constant inside that D. Now in the next step, after traversing half a cycle, the ion comes to the edge of D2. if we adjust the frequency of the oscillator in such a way that by the time ion comes to the edge of D2, potential difference changes direction so as to make D1 negative and D2 positive. Go back to the figure. Now when it comes towards the edge of D2, if we change the polarity, here this will become positive and the other end becomes negative, means I am changing the polarity. Now this end becomes negative. Now in this case, the positive ion gets attracted towards D1, and during this process, when it during the movement, inside this electric field, the electric force makes the particle to accelerate, means it gains some energy or its velocity increases. When the velocity increases, the radius of the path will also increase. So the frequency has to be adjusted in such a way that when it reaches the edge of D2, the polarity has to change, and now D1 has to become negative and D2 becomes positive. When D1 becomes negative, this is a positive ion, it gets attracted towards the D1. The ion will then get attracted to D1 and its speed will increase due to acceleration. So this is important, speed will increase due to acceleration, and because R is, we know the formula, R is mv by qb. When velocity increases, radius also increases. That is why path is shown like this, with increasing radius. At each time the radius increases. Once inside D1, the ion is now in electric field free zone. So we know inside the G there is only magnetic field, and hence there is no acceleration inside the D. Inside D only magnetic field is acting, and it makes the particle to move in a circular path. No acceleration, no change in the speed inside the D. So inside D it is an electric field free zone, and again it will move in a circular path with constant speed which is higher than the previous constant speed in D2. So the speed has now increased. Radius of path in D1 will be larger than D2. That's how it is shown here. This was the initial path. Now the radius has increased, and again it further increases. So repeatedly it keeps on happening. You keep on changing the polarity. That is why we have used a high frequency oscillator or alternating source which will change the polarity. So this process repeats itself again and again, and every time it enters the field, electric field, it gets accelerated, and due to this acceleration, that means the velocity increases and the particle starts gaining high energies. After traversing the semicircular path in D1, the ion will come to the edge of D1. Now again, when it comes to the edge of D1, you change the polarity and the particle will be attracted towards D2, and this continuously happening repeatedly. This process is happening, and it receives a very high energy during this process. This way the ion will continue travelling in semicircular of increasing radii every time it goes from D2 to D1 and from D1 to D2. Now time taken by the ion to traverse the semicircular path in the D is given by T is pi r by V. So this is for the semicircular path. The time is given by circumference of the semicircular, pi r divided by V, and we know the radius r is mv by qb, so it is pi into pi by v into radius is mv divided by qb. and the VV will cancel. So time period becomes equal to T becomes equal to pi into M divided by Q into B. So time period of total motion, time period of the motion, that means time period to complete one circle will be 2t. Two pi m by qb. Or the frequency will be equal to 1 by t. The frequency, if I write frequency, frequency of this motion is equal to 1 divided by 2t, or 1 by capital T, which is equal to 1 by this. So qb goes to qb divided by 2 pi m. The frequency of its motion is given by qb divided by 2 pi m. So this frequency we can call as it as cyclotron frequency, which is independent of radius of the semicircular, and also the independent of the velocity of the charged particle. If you see the frequency, this frequency is known as cyclotron frequency, and the important thing is it is independent of the radius of the semicircular path and also the velocity of the charged particle and also the type of the particle. The radius of the, but it depends upon B and Q, the type of the charge of the particle and also the mass of the particle, but it is independent of the radius of the path followed and also the velocity which the charged particle gains. Now the thing is, we need to set, now this is the frequency of the motion, so the alternating source whatever we are connecting, its frequency we need to adjust to this frequency, so that automatically its polarity changes when the charged particle reaches the edge of the Ds. So this is the frequency which you have to set for that alternating source. This is about the working principle of cyclotron. Hope you understood this.